Okay, this evening I'm going to talk about climate change. And when most people hear the term climate change, they often think of global warming and its implications for the future. And while that's an important and highly debated topic, it's not the focus of my talk this evening. Instead, I'm going to be discussing climate change in the ancient past. Subjects which scientists from a number of different fields have studied extensively using a variety of tools. And this, I think, is an equally interesting territory to explore. Now, while I won't be delving into modern global warming, I couldn't resist starting with a lighthearted cartoon about it, which you'll see on the first slide. And I came across this cartoon years ago in someone else's presentation on the topic of global warming. So I can't take credit for it, but I thought it was worth sharing for a good chuckle or laugh. So moving on, the next slide is my title slide, introduces my talk. And you'll notice that I've used the word miracle in the title. And that's because tonight's presentation is about God's handiwork in transforming the earth into a unique habitable home that we enjoy today. And as we examine this remarkable process, we'll draw insights from both science and scripture, focusing on how Earth's surface was shaped to create the climate that we now experience. Now, you may not know this, but the climate over the past 9,000 years is unlike anything else in Earth's 4.5 billion year history. Over this period, the planet has enjoyed a temperate climate regulated by natural processes that keep temperatures within a narrow range where humans can not only survive, but can thrive, and not least just simply enjoy. Now, many climatologists refer to this period as a long, warm spring. Before this era, Earth has never experienced a climate like ours of today. So let's take a look in the next slide at a chart of global temperatures over the past 17,000 years. This graph illustrates a remarkable transformation. Around 9,000 years ago, Earth's climate shifted dramatically from one with wide temperature swings to one with extraordinary stability. Now on this chart, time zero represents the year 2020. And then the temperature scale measures global temperature changes relative to the average global temperature in 2020. Now you'll notice two distinct lines. There's a blue line, which represents the last 9,000 years, characterized by minimal temperature fluctuations. And then the maroon line shows the prior 8,000 years, which were marked by extreme temperature swings. This sudden transition 9,000 years ago is remarkable. It marked the beginning of a stable temperature climate that has allowed Earth to support billions of people. Without this stability, human civilization as we know it would not have been possible. Now, let me add a note about the graph. If one looks closely at the blue line, you may be able to see at the far right a small, sharp uptick in temperature. And this reflects the current global warming. So then to go on, to sum up, we've been blessed with an exceptionally stable climate that stands in stark contrast to Earth's volatile climate past. Later, we'll see more of the Earth's extreme climate change in the ancient past. But today's climate is not just a product of chance. It reflects the intricate processes that have shaped our planet and I believe the providence of God in creating a home uniquely suited for life, and in particular for complex life. So let's take a step back and explore some of Earth's history. Has Earth experienced climate change in the past? Well, the answer is definitely yes. And at times, the changes have been extremely severe. For example, there were at least two periods in Earth's history where the entire planet was covered with ice and snow. And these periods were known as snowball Earth. Now, in fact, climate has been a constant feature of our planet ever since Earth developed an atmosphere 4 billion years ago. Genesis gives us a poetic account of this event during the second day of creation, where it describes the separation of the waters above from the waters below, and with the sky in between. The waters above refer to the clouds, and the sky in between is our atmosphere. And whenever you have an atmosphere on a planet with moving tectonic plates and orbiting a star, you inevitably have weather and climate change. Now, the history of Earth's climate change is written in the rocks and the fossils and the formations and the structures, which geologists and geochemists and planetary scientists and other scientists have learned to study and interpret. So we'll take a close look at what they have learned and how the remarkable transformation which created our climate came about. So to begin, let's turn the clock back about 300 million years to examine what Earth looked like at that time. It was vastly different from the planet that we know today. The continents we recognize now didn't exist in their current form at that time. Instead, all the land masses were joined together in a single giant planet called Pangaea. And we'll take a look at Pangaea on the next slide and see what it looked like. So this aligns with the Genesis account of creation. Genesis 1:9 tells us that God gathered all the waters into one place, allowing dry ground to appear. If all of the waters were gathered into one place, it follows that all the land would also be in one place. And this landmass, as we now know, was the immense supercontinent called Pangaea. Now, over the next 300 million years, tectonic forces broke Pangaea apart, forming the seven continents that we recognize today and reconfiguring them into their current positions around the globe. You can see on the slide which parts of the supercontinent are current continents together with their current countries came from. For example, the eastern seaboard of North America once joined to West Africa. Similarly, Brazil was connected to West Africa as well, while India was positioned far south in the southern hemisphere joined to East Africa. So given that we know that this supercontinent broke apart, creating continents that we have now, and the new continents were moved into their current positions, we have to conclude that this was part of God's plan, because nothing happens on Earth outside of his divine purpose. So now let's pose a question. Why did God, so to speak, rearrange the future of the Earth? While we can't know his reasons with certainty, I'd like to offer some speculation based on evidence from both scripture and science. Now, if God's plan was to transform the earth into a home suitable for mankind, we have to wonder why Pangaea wouldn't have served its purpose. What was lacking in this nice piece of real estate as a future home for mankind? Some might speculate that having all humanity on one continent might have led to even worse wars, even more wars, and greater chaos than we have now. But I don't think that this was the primary reason. To arrive at a reasonable answer, let's look at Scripture. In Genesis 1:28, God speaks to Adam and Eve. And in this verse, it is written, God blessed them and said, be fruitful and increase in number, fill the earth and subdue it. And later in Genesis 9:1, God repeats the same command to Noah and his sons after the flood. It says there, then God blessed Noah and his sons, saying, be fruitful and increase in number and fill the earth. Now, when God repeats himself, we can be sure the instruction is vital to his plan. So what does fill the earth mean? Well, certainly it doesn't mean shoulder to shoulder or standing at arm's length. Instead, I believe it suggests reaching a population that the earth has the capacity to support. So how many people would that be? Well, it's at least 8 billion, the current population of the earth. While many people live in poverty or are undernourished, it's still remarkable that our planet sustains that number of lives. Now, there is additional evidence in Revelation 7:9, which is shown on the next slide. And it describes a vision of heaven. And here's what it says. After this, I looked, and there before me was a great multitude that no one could count, from every nation, tribe, people, and language, standing before the throne and before the Lamb. They were wearing white robes and were holding palm branches in their hands. Now, in John's vision, the multitude in white robes were all people who were in heaven after the end times. This would include all people who are saved during their time on earth, through the history of mankind, right up to the end of current earth. The verse says that the number of people were uncountable. But what does that mean, uncountable? Well, Hugh Ross wondered about this and studied the Greek term used by the Apostle John, and found that in the Greek counting tradition of that time, numbers over 1 billion were considered uncountable. So this suggests that the number of people in John's vision could be in the billions, aligning with approximately 2 billion Christians living on earth today and perhaps 1 billion from the past. For God's plan then to support billions of people, Earth needed the capacity to produce food and sustain life on a massive scale for millions of different species. Pangaea simply didn't have that capacity. The primary reason for this was its climate. Pangaea had an extremely hot, dry, and harsh environment, with most of the land being arid. If Pangaea existed today, it would be even hotter because the sun is now 3% brighter than it was 300 million years ago. And additionally, there was no snow or ice on Pangaea to help cool the land. So as a result, the climate would have been even worse than Australia's interior, which is a vast region which supports only a sparse population due to its dryness. Now, another limitation of Pangaea was its biodiversity. Most of the animals living on Pangaea were reptiles and amphibians such as lizards, snakes, and monitors, not exactly the kind of creatures you'd want on your dinner table. On the next slide, you'll see an example of one of the major species that lived on Pangaea. This creature could grow up to 15 feet long and weigh 550 pounds. And whilst fascinating, it doesn't look very appetizing. So this supercontinent, Pangaea, would not have worked as a home sweet home for several billion people. To transform the Earth into a suitable habitat, a climate like the one that we have today had to be created. And achieving this required several major steps. First, the supercontinent had to be broken into 7 individual continents, which were then strategically positioned around the planet. This new configuration created a pattern of ocean and air currents that efficiently distribute heat across the globe, balancing the climate. Now, second, some specific land masses had to be placed in precise locations to support the formation of immense storehouses of ice, particularly in the polar regions. These ice masses act like a heat exchanger in an air conditioning system, cooling the circulating air and water currents that regulate global temperatures. And third, most of the land masses, or most of the land mass, needed to be moved into the cooler northern hemisphere. This was crucial because the southern hemisphere receives more intense light due to the tilt of the Earth, making it generally hotter than the north. And later I'll show you an image of the resulting distribution of landmass on our continent. Now this orchestration of these 4 steps seems highly unlikely to have occurred by undirected tectonic movement alone. In fact, Scripture points to divine involvement. In Isaiah 44:24, God declares, "I am the Lord, the maker of all things, who stretches out the heavens, who spreads out the earth by myself." So this verse affirms that it was God himself who moved and spread out the earth, the land masses. And he could have achieved this by directing the tectonic forces, using them as part of his divine design. So let's look at the next slide to see how the spreading of the earth masses occurred. The slide illustrates key stages in the breakup and movement of the continents. The top image shows the land masses as they appeared 250 million years ago, about 50 million years after the breakup of Pangaea began. This was also the time when the dinosaurs appeared on Earth. And I don't think any of us would have wanted to live back then with a T-Rex in our backyard. Now, the middle image shows the Earth as it was 100 million years ago. And at this point, India had broken away from its original position and was an island, became an island, still located deep in the southern hemisphere. And meanwhile, Antarctica and Australia were still connected in a single landmass. And then finally, the lower image shows the Earth as we know it today. India has moved all the way north and joined Asia, forming the Indian subcontinent. Meanwhile, Antarctica and Australia have separated and completely and have drifted apart. Now, the next slide illustrates how the land masses are currently distributed between the northern and southern hemispheres. On the left, you see the northern hemisphere, and on the right, the southern hemisphere. As you can see, the majority of the landmass is located in the northern hemisphere, as I pointed out earlier, is critical. To give you the numbers, 39% of the northern hemisphere is land, compared to just 19% in the southern hemisphere. Now, one notable feature in the southern hemisphere is Antarctica, which has settled directly over the South Pole. Over the course of several million years, this landmass accumulated the world's largest deposit of ice. The Antarctic ice sheet contains a whopping 7.2 million cubic miles of ice, and in some places it is miles deep. Now, recently, a research team extracted the first ice core drilled all the way to bedrock, and it was 1.7 miles long, and it spans a time of 2 million years. So this immense ice sheet cools the Earth in two ways. First, it cools the water and air currents that circulate around it and over it. These chilled currents then flow across the planet, helping regulate global temperatures. And second, the ice reflects more of the sun's heat and light back into space than does land, which reduces the amount of heat absorbed by the planet. Together, these cooling mechanisms make Antarctic's ice sheet a vital component of Earth's current climate system. Now, the movement of Greenland to its current location is one of the most remarkable relocations in the reconfiguration of Earth's landmasses. Originally, Greenland was situated near the equator. Now, if the movement of landmasses were a chess game, Greenland would have been a knight. It moved in a straight line to the north and then made a sharp left turn to reach its final destination. Now, about 30 million years ago, Greenland was positioned at the approximate latitude of England. By 5 million years ago, it had reached the location shown at the back of the end of the arrow on the next slide. Then it made its sharp left turn to settle into its current position as indicated by the point of the arrow. Now this sharp turn in Greenland's path was highly unusual because tectonic forces don't typically produce abrupt changes in direction. Recently, geophysicists discovered that this shift occurred because the entire tectonic plate carrying Greenland rotated westward, causing Greenland's path to veer to the left. Now, Greenland's final resting place is also extraordinary. It came to rest directly over an immense lava plume, which uplifted Greenland to an elevation of around 2 miles at its highest point. Now, while Greenland was far enough north to form some ice at its original elevation, its current high elevation enabled it to develop an enormous ice sheet, which at 0.7 million cubic miles is now the second largest on the planet. Greenland's ice sheet is also a vital component of Earth's climate system. Now, another critical impact of Greenland's location is its role in blocking the eastern end of the Arctic Ocean. This geographic obstruction caused the Arctic Ocean to ice over, further influencing Earth's climate by helping regulate global temperatures with about 2,000 cubic miles of ice, which is the fourth largest. The fine-tuned movement of a landmass from Pangaea to contribute to the Earth's storehouses of ice is just as remarkable as Greenland's journey. Earlier we discussed how the Indian subcontinent broke away from a portion of Pangaea that was located deep in the southern hemisphere. What makes India's journey extraordinary is that it moved northward at a hypervelocity, 5 times faster than the normal speed of tectonic motion. The next slide illustrates the path of India's remarkable journey. At about 23 million years ago, the Indian subcontinent slammed into the Eurasian continent. And this collision at hypertectonic speed forced the continental landmass upward, forming the Himalayas and the Tibetan Plateau. Now today, the Tibetan Plateau, often referred to as the roof of the world, stands at an elevation of about 3 miles, which has led to the creation of the third largest deposit of ice on Earth, containing about 2,500 cubic miles of ice. It is the highest and largest plateau on Earth, and it was because of the hypervelocity impact that the plateau reached such a high elevation, and enabling it to become a massive storehouse of ice. Now, this ice deposit not only helps to cool the planet, but it also serves as a source of a vast network of rivers that irrigate the extensive agricultural fields in the lowlands of Asia. Additionally, it drives the annual monsoons that these crops depend on. The next slide highlights some of the major rivers originating from the Tibetan Plateau, which provides lifelines for billions of people. 50% of global agricultural foods come from Asia, are produced in Asia. Now, does the formation of the Earth's great ice storehouses, like those in Greenland, Antarctica, and the Tibetan Plateau and the Arctic, find any mention in Scripture? I believe it does, as referenced in Job 38:22, which is shown on the next slide, which says, have you entered the storehouses of snow, or seen the storehouses of hail? So another key factor in Earth's climate control is the precise ratio of land to water that God designed. Approximately 30% of the Earth's surface is land, while 70% is water. This balance is essential because water reflects more sunlight than land. If there were more land, the Earth would absorb too much heat, making it too hot to support advanced life. If there were more water, the Earth would reflect too much sunlight, causing it to cool excessively. Ice, as we've seen, covers much of the Earth's surface, is highly reflective of sunlight, and plays a vital role in this delicate balancing act. Now, the breakup of Pangaea into 7 continents and their subsequent repositioning into specific locations is what ultimately created the temperate climate we enjoy today. Now, as mentioned, a critical consequence of this finely tuned arrangement of the continents was that it established a pattern of atmospheric air currents and ocean streams that generate our weather and regulate global temperatures. So is there anything mentioned in Scripture about these currents? Oh, indeed there is. The person who first made the connection was Matthew Maury, who was known as the scientist of the seas, and is now considered the father of modern oceanography. He was also known as a man of the book. And one day, Psalm 8:8 caught his eye, where it is written, "And the fish of the sea, all that swim the paths of the sea." So he took the Bible literally, and this verse got him thinking that there must be certain strong currents in the oceans, like the rivers of water flowing through certain parts of the oceans. In the mid-1800s, he set out to search for them, and he found them and he mapped them. And being an officer in the Navy made this task easier. The Gulf Stream is one example of these ocean streams. Now, Maury then decided he was onto something. He started wondering, Are there similar streams in the atmosphere? So he turned again to Scripture and found Ecclesiastes 1:6, where it is written, "The wind blows to the south and turns to the north. Round and round it goes, ever returning on its course." He searched for air streams in the atmosphere, and he found them as well. And one notable example is the airflow between the equator and the Arctic. At the equator, the heat of the sun warms the earth, which causes it to rise into the upper atmosphere. This warm air flows north to the Arctic, where cooler temperatures cause it to descend to the surface. The air then flows back, near the surface back to the equator, completing a circular pathway. As Ecclesiastes describes, round and round it goes between the equator and the Arctic. We experience this air movement as cold fronts in the winter, which move across our country from north to south. Now, in addition to this pattern, Maury also discovered other air currents, the jet stream, for example. And together, these ocean and air currents form an essential part of the natural system which God designed to regulate the planet's climate. Now, I'd like to next reference a couple of scientists who have commented on the critical importance of the configuration and features of the Earth's continents on our weather and climate. The next slide shows one of them by Hugh Ross. There's a lot to read there, so the most important sentence is the last one, so I'll read that sentence. Researchers now recognize that this exact arrangement of continents, oceans, and seas maximizes the amount of land area receiving sufficient precipitation to sustain widespread human civilization. The first sentence has a very important phrase too. Earth's current continental configuration represents something more than a random lucky for life outcome. Now the next slide is from a blog by Kevin Birdwell, who is a climate scientist at Oak Ridge National Laboratory. Again, a lot of text. I'll read again just the last sentence. The distribution of oceans and the present continental configuration suggest design climate stability. Without this thermostat, climate changes that occur on human timescales would be more abrupt and more disruptive to society than those that have been observed. Now let me briefly turn to another consequence of the creation of the 4 immense storehouses of ice that I mentioned. This triggered the beginning of an ice age cycle about 2 million years ago, something that had never happened before in Earth's history. And the next slide illustrates the ice age cycle over the last 400,000 years. Now on the graph, the dotted line represents the Earth's temperature at the time the graph was made. And the temperature scale then shows degrees above this average and below, measured in degrees Celsius. Now during the coldest parts of the cycle, the ice age cycle, temperatures dropped about 9 degrees centigrade, which would be about 18 degrees Fahrenheit, below the current temperature. Now the red peaks represent the warm periods within these cycles. These ice age cycles have occurred approximately every 100,000 years, and we are currently in one of the warm zones, as indicated by the red box on the slide. Now notice a couple of interesting features. First, in all the previous warm periods, the temperatures actually rose higher than they are today. And second, our current warm period has lasted longer than those in the past. And as mentioned earlier, this extended warm period has been crucial for the development and flourishing of human civilization. So this brings us to the modern era. And before I conclude, I'd like to take a step back and consider where Adam and Eve might have fit into this timeline of ice ages. One of the oldest known fossils of a fully modern human skeleton was recently discovered in Israel, just a few days from the Tigris and Euphrates rivers, which Genesis tells us flowed through the Garden of Eden. These fossils were dated to approximately 110,000 years ago. Now, if this individual lived around the time of Adam and Eve, it would place their existence near the peak of the last warm period, as shown on the next slide. Now, this timing would make sense, as God would likely have chosen a pleasant climate for Eden and his first humans. But then came the fall, and you might say this was followed by winter, a very severe winter, as Earth transformed into the last ice age. Humanity, it seems, had to endure an ice age before the arrival of our current warm period, extended warm period. If they did start to spread over the Earth at this period, they probably went south into Africa for a warmer climate. And numerous ancient human fossils have been found in Africa. Now, to put this into perspective, I searched for estimates of the world's population 10,000 years ago, which is about when the extended warm period began. And the numbers ranged between 1 and 10 million people, which is a stark contrast to the population of a single large city today, like Tokyo, which is home to about 37 million people. So clearly, humanity did not significantly increase in numbers to fill the Earth until the advent of our extended temperature climate. So with that thought, I'll conclude.